T2V1, a two-place single-jet high-performance trainer. The purpose of this film is to familiarize you with aircraft systems and with pre-flight, normal, and emergency operating procedures. The wingspan is almost 43 feet. The fuselage length is about 36.5 feet. The height from ground line to top of vertical fin is almost 13 feet. The gross weight of the airplane is approximately 16,700 pounds. The hydraulic, fuel, and electrical systems are designed for maximum reliability and simplicity of operation. The hydraulic system operates aileron boost, boundary layer control valves, speed brakes, landing gear, a resting hook, wing slats, and furnishes power for the wheel brakes. In the event of failure of the main hydraulic system, lower the emergency landing gear control lever to the emergency position. The landing gear will extend, but cannot then be retracted. The fuel load, totaling 4,950 pounds, is carried in fixed tip tanks, in a fuselage tank aft of the cockpit, and in wing tanks. Pilot-controlled dump switches allow fuel to be dumped from the tip tanks. Fuel is force-fed from the tip tanks to the fuselage tank. It is gravity-fed to the wing tanks, then pumped directly to the engine. The entire system is fully automatic, requiring no pilot surveillance for continuous operation during flight. The major components of the DC electrical system are the generator, the battery generator switch, the annunciator panel, and the primary and secondary buses. In the event of generator failure, the generator out light will glow. DC power from the battery is removed from the secondary bus as all available battery power is diverted to the primary bus. To restore power to the secondary bus, place the battery generator switch in the bat-only position. Or place the landing gear control in the down position. The major components of the AC instrument power system are a 250-volt ampere inverter supplying AC power to the flight instruments, a 1,500-volt ampere inverter supplying AC power to the electronic equipment, the flight instrument power supply switch, and the annunciator panel. The instrument out light on the annunciator panel indicates the failure of the 250-volt ampere inverter and the loss of power to the flight instruments. To restore power to the flight instruments, place the instrument power switch in the standby position. Instrument power will be supplied by the 1,500-volt ampere inverter. The T2V is equipped with a forced air boundary layer control system to increase low-speed stability and to lower stalling speed. When the boundary layer control switch is placed in the on position, air is bled from the engine compressor manifold and forced over the surface of the wing flaps. The flow of boundary layer control air over the upper surface of the flaps eliminates trailing edge turbulence, thereby increasing lift. Now, a selective treatment of pre-flight procedures. The first step in pre-flight procedure is the exterior inspection of the aircraft. There are several inspection points unique to the T2V1, which must be included in the normal walk-around inspection. The T2V is equipped with leading-edge wing slats. Manually retract and extend the slats to check for freedom of movement. Check to see that the spoiler in the inboard section of each slat remains extended slightly when the slat is retracted. Ram air orifices are located in the nose of each tip tank. Check them for obstruction. Likewise, check the fuel dump outlet in the aft underside of each tip tank for obstruction. Check the boundary layer control orifice in each wing for obstruction or corrosion. Check each aft speed brake for signs of wear or improper alignment. There is a small glass port in the snubber unit of the arresting hook through which you can check the position of the snubber piston. Check to determine that all tailpipe mice are secure. The main hydraulic reservoir is located in the upper left fuselage, just aft of the cockpit. Check the sight gauge on the main hydraulic reservoir for proper fluid level. Now let's move into the front cockpit. Cockpit controls and instrumentation are grouped according to function. The left panel is devoted mainly to engine and fuel controls. The instrument groupings include engine performance, aircraft performance, navigation, and fuel. Two components of the instrument panel are unique. The first is the annunciator warning panel. The second is the fuel quantity gauge. 9 of the most important warning indications are included in the annunciator warning panel. Canopy unlatched, fuel filter out, generator out, fuel level low, engine fuel pump fail, instruments out, turn and slip out, oil pressure worn, and hydraulic pressure low. The fuel quantity gauge and indicator panel are located on the right side of the instrument panel. The fuel quantity gauge normally indicates the total weight of fuel in the inboard tanks only. Press the center switch to determine the total weight of fuel in the inboard tanks and the left tip tank. Press the lower switch to determine the total weight of fuel in the inboard tanks and the right tip tank. Press both switches simultaneously to determine the total fuel aboard. The right panel and console contain electrical, navigational, air conditioning, and lighting system controls. The following items in the pre-start cockpit check are unique to the T2V, or of sufficient importance to warrant attention. The pre-start cockpit check moves from left to right around the cockpit. Tip tank shutoff switches open with red guards down. Tip tank dump switches off with red guards down. Tip tank depressurization switch normal with red guard down. Oxygen supply valve on. Main fuel shutoff switch open with red guard down. Interphone panel settings on the center stand set as desired. Now to the right side panel. Switch off. Flight instrument power switch off. Cabin defrost switch normal. Cabin air switch on. Cabin pressure dump switch normal. Cabin temperature selector set as desired. Cabin temperature override switch on auto. Again, the previous items are not a complete pre-start cockpit check for the T2V, but merely a coverage of unique or highly important checkpoints. We move now to normal operating procedures, including starting, takeoff, stall, and landing. Starting is accomplished by air impingement on the engine compressor vanes. Wait for the crewman's signal that the air impingement hose is secure. Turn battery generator switch to BAT Gen position. Place the ignition switch in the on position. Signal the crewman to begin air impingement. When the tachometer reaches 8%, move the throttle to the ignite position, hold momentarily, then move it to the idle position at 10%. Light off should occur within 10 seconds. Prime the engine as necessary until it reaches idle speed, 38%. When the engine has stabilized at idle speed, the exhaust gas temperature should stabilize at about 550 degrees. Signal the crewman to disconnect the air impingement starter. Place the instrument power switch in the normal position. Then proceed with your post-start cockpit check before taxiing. Check RMI for alignment, which is accomplished by adjustment of the S2 compass controller. Press the annunciator panel test button, All segments of the panel should light. Press the fire detector test switch. Both the aft overheat warning light and the plenum fire warning light should go on. Press the fuel quantity indicator test button for a 0 reading. When released, the gauge needle should return to its original reading. Then, press the middle and lower buttons to check the total fuel aboard. Check communication and navigational control panels for proper settings. You are now ready to taxi the aircraft to the takeoff end of the runway. Check the annunciator panel for lights out. Check all red switch guards on the left panel for down. Go over the takeoff checklist. After takeoff clearance is obtained, move into position on the runway and hold the brakes. Advance the throttle to the fully open position. Check the tachometer for 100% RPM. Exhaust temperature should not exceed 704 degrees. Release the brakes. Use braking action for directional control up to about 50 knots. Then, use rudder control. Raise the nose wheel at about 85 knots. Fly the aircraft off the ground at about 115 knots. Raise landing gear when comfortably airborne. Raise flaps at approximately 150 knots. An unaccelerated stall will demonstrate inherent flight stability. To initiate a normal stall, slowly raise the nose of the aircraft. When the angle of attack reaches or exceeds 22 degrees, a mechanical stick shaker will warn you of the situation. To recover from the stall, release back stick pressure and apply full power. The T2V stalls and recovers with no tendency to assume unusual attitudes. The normal landing procedure is similar to that applicable to any conventional tricycle landing gear aircraft. Start your letdown to traffic pattern altitude, reduce power, and extend your speed brakes. Then lower your landing gear and your flaps when speed is below 217 knots. Fly your downwind leg about 4,500 feet abeam the runway and continue to reduce speed. Begin your 180 abeam the touchdown point, speed 140 knots. At the 90, 130 knots. Continue reducing speed and maintain a shallow glide path during the final approach. Touchdown at about 105 knots. Retract flaps when the nose wheel touches down to reduce lift and increase traction for braking. Knowledge of emergency operating procedures is a cardinal requisite for flight operation of this or any other aircraft. Ejection procedures for the T2V are similar to those prescribed for all high-performance naval aircraft. Following is a simulation of those procedures. Once the decision to eject is made, place your feet in the stirrups and sit erect in the seat, head braced against the headrest. Pull the emergency bailout bottle and disconnect the oxygen hose at the mask connection. Grasp the face curtain handle. Pull down to the full limit of travel, firing the canopy and ejecting the seat. If the canopy does not jettison, pull the auxiliary canopy jettison handle or push the canopy lock handle full forward and press the canopy open switch. If none of the above procedures jettisons the canopy, pull the canopy interlock release handle. Then pull the face curtain to the full limit of travel, ejecting the seat through the canopy. The air start is another emergency procedure with which you must be acquainted. Immediately upon flame out, move the throttle to the off position. Maximum altitude for an air start is 25,000 feet. Descend to that altitude if necessary. Then assume a glide of 200 knots. At this speed, the engine will windmill at 8 to 10% RPM. Then drain the tailpipe of residual fuel. Place the plane in a shallow dive. Move the ignition switch to on. Place the battery generator switch in the bat-only position. Move the throttle to the ignite position, hold momentarily, then slowly advance it to the idle position. Prime the engine as necessary to altitude idle RPM. Light off should occur within 15 seconds. If air starts are unsuccessful, a flame-out approach may be attempted. Here is a stylized illustration of the flame-out landing pattern, a 360-degree approach with 3 fixed checkpoints. The high key, above and outboard of the intended touchdown point, the middle key, about 5,000 feet abeam the touchdown point, and the low key. Adjust your glide path to reach the high key at an altitude of 5,000 feet. Lower gear and flaps. Simulated flameouts may be practiced by using speed brakes. Maintain approximately 150 knots throughout the approach, assuming a 2,000-pound fuel load. Pass over the middle key on your downwind leg at an altitude of 2,600 feet. Decrease altitude to pass over the low key at 1,500 feet. Try to reach the straightaway with a minimum of 600 feet. Touch down at about 120 knots. As in normal landings, retract flaps when the nose wheel touches down to reduce lift and increase traction for braking. This completes our overall review of pre-flight, normal, and emergency procedures pertinent to the T2V. Subsequent films and training will, of course, treat these procedures in specific detail.